electroscope, this top part is electrically connected to the post and to a pointer. So when the electroscope is charged, the top and the post and the pointer will all have the same charge. Now I want to make sure that the electroscope has no charge, so I'll touch it, and the excess charge in the electroscope would go into my hand, leaving the electroscope neutral. The classic way to get a negative charge is to rub a rubber rod with wool or animal fur. When you do that, electrons are transferred from the wool to the rubber, leaving the rubber with a negative charge and the wool with a positive charge. When I touch the charged rubber rod to the electroscope, I transfer some of that negative charge to the electroscope. I'll have to go through this procedure several times to transfer enough charge for us to see the effect. The pointer is now rotated away from the post, which tells us that the post and the pointer have the same charge because like charges repel. So the top of the electroscope and this bottom of the electroscope are all negatively charged. Now I'll ground the electroscope to make it neutral, and then I want to put a positive charge in the electroscope. The classic way to get a positive charge is to rub the glass rod with silk. When I rub the glass with silk, electrons are transferred from the glass to the silk, leaving the glass with a positive charge and the silk with a negative charge. I can then touch the charged glass on the electroscope to transfer charge to the electroscope, and I'll have to do that again several times to get a significant charge on the electroscope. Now, do that a few more times. Alright, now the electroscope has a significant positive charge, but you'll notice that the electroscope looks no different when it has a negative charge than it does when it has a positive charge. In both cases, the post and the pointer have like charges, and like charges repel. So we need a way to find out what the charge of the electroscope is. What we can do is bring a known charge close to but not touching the top of the electroscope and see what the pointer does. We'll bring a known positive charge close to the top of the electroscope and notice that the pointer moves farther away from the post. The reason for that is that the positive charge of the glass repels some positive charge, some additional positive charge down to the bottom of the electroscope. That makes the positive charge down here stronger, and the pointer rotates away from the post. If I test that with a negative charge close to the top of the electroscope, you see the pointer moves closer to the post. So what's happening there is that some of the positive charge from the bottom of the electroscope is attracted to the top because opposite charges attract. That leaves the bottom of the electroscope with a little bit weaker positive charge, and the pointer moves a little bit toward the post. So we know that this electroscope has a positive charge. Next, what we want to do is use a known charge on the electroscope to figure out what an unknown charge is. So what I have here is a strip of vinyl and some acetate cloth, and I want to rub the vinyl with the acetate and bring that close to the top of the electroscope to see what the pointer does. And you have to do this several times. Alright, this worked last night. There we go. So we move the unknown charge close to the top of the electroscope. That causes the pointer to move a little bit closer to the post. So we know that that means that the charge on the bottom of the electroscope was a little weaker than it was before. We know it had been a positive charge. It was a little weaker positive charge down here, so that means that some of the positive charge must have gone to the top of the electroscope. It did that because it was attracted to the negative charge on the vinyl. So now we know that the charge on the vinyl had a negative charge.